Hi, this is Jane. In this video, we will talk about conducting an ANOVA test using Microsoft Excel. Let's get started. If you've watched our video that explains the concept of a one-way ANOVA test, you may recall that a one-way ANOVA test helps you figure out when you really do have apples, oranges, pears, etc. in your data, where the different fruits are different groups of people. In this example, we are going to take a look at average overall rating for the festival by time at festival, using 4 groups for time at festival: 31 to 45 minutes, 46 to 60 minutes, 61 to 90 minutes, and more than 91 minutes. The overall rating question asked festival attendees, how would you rate today's event overall? Festival goers could choose an answer on a 5-point scale from poor to excellent. Here, time at festival is the predictor variable. We want to know if the time spent at the festival predicts differences in overall rating. Overall rating is our outcome variable. It is the variable that we want to learn more about. To get started with this analysis in Microsoft Excel, we must first create a worksheet that contains one column of data for each group in the predictor variable time at festival. These columns will include the overall rating code for each individual in each of the 4 groups. Here is the worksheet that contains the data we will use to conduct the one-way ANOVA test. Column A contains the overall rating data for festival goers who had been at the festival for 31 to 45 minutes. Column B contains the overall rating data for festival goers who had been at the festival for 46 to 60 minutes, and so forth. You will need to have the Data Analysis Tool Pack loaded in Excel. Click on the Data tab, and if you don't see the Data Analysis icon at the top right, you will need to load this tool pack. To add it, go to Tools and click on Excel Add-ins. Check Analysis Tool Pack and click OK. When you restart Excel, you should see the Data Analysis icon within the Data tab. Click on Data Analysis. Click on ANOVA Single Factor and click OK. Click in the Input Range box and highlight all of the columns containing overall ratings data. In this example, that is columns A through D. Make sure you indicate that the data are grouped by columns. Check the box next to Labels in first row to indicate that row 1 contains labels. Click the radio button next to Output Range and click in the Output Range box. Click in the one cell on the worksheet where you would like Excel to begin displaying the output. Click OK. And this is what your output should look like. These are your results. Excel provides a summary table of information as well as the results of the ANOVA test. The summary table shows the size of each group, as well as each group's mean and variance, which is related to the standard deviation. If you've forgotten what the standard deviation is, please visit our website to watch a refresher video. If the group sizes are very different from one another, you should ask yourself if an ANOVA test is appropriate and whether or not to proceed. Here, our groups are fairly close in size, so we can feel confident to continue. The ANOVA results table provides information about 2 types of variance, the between groups variance and the within groups variance. We also see the degrees of freedom, the value of F, and the p-value. You are most interested in the p-value to determine if you have differences between one or more pairs of time at festival groups. If the p-value is less than 0.05, that means you do have differences. In more statistical terms, you use the p-value to determine if the mean of the outcome variable differs between at least 2 of your groups. For this scenario, we see that our p-value is 3.33 times 10 to the negative 15th. That number is less than 0.05, which means that we have one or more pairs of time at festival groups that differ significantly in average overall rating of festival. Note that the p-value simply tells you if there are pairs of groups for which the ratings are different. It doesn't tell you which groups differ significantly from one another. To figure that out, we have to run what is called a post hoc test. Excel doesn't have a way to conduct a post hoc test that compares all of your groups to each other at one time. So you will have to conduct a series of separate post hoc independent samples t-tests for each pair, in this case 6 tests. If you've forgotten how to run an independent samples t-test in Excel, please review the video available on our website. Remember that the p-value is the risk that your results are actually from chance and not based on a real difference in your data. The value, p less than 0.05, is the acceptable risk for one test. If you do more than one test, you have to adjust your risk level to help make sure that your estimates account for the extra level of risk. The more tests you conduct, the greater the possibility of making the wrong decision based on the p-value, so we adjust it for each post hoc test we do. In this example, the number of tests we have to do is 6, so we divide 0.05 by 6. This makes it more difficult to get a statistically significant result, but if we do, then we know that we have reassessed our risk level in a way that gives us confidence in our results. In this case, if the p-value for an independent samples t-test is less than 0.05 divided by 6, or 0.008, then you know that the average overall rating between the groups being tested is different. You have apples and oranges. Because the average overall rating increases at each increase in time at festival, when we test each pair using an independent samples t-test, we can use the p capital T less than or equal to small t one-tailed p-value for comparison to 0.008. The results of the 6 post hoc independent samples t-tests show that there are significant differences in average overall rating between the following groups: 31 to 45 minutes and 61 to 90 minutes, 31 to 45 minutes and more than 91 minutes, 46 to 60 minutes and more than 91 minutes, and 61 to 90 minutes and more than 91 minutes. So how do you think about interpreting these results? Remember that these ratings were made on a 5-point scale, where 1 was poor and 5 was excellent. The average ratings were above 4.0 for all groups, so somewhere between very good and excellent on the scale. When interpreting these kinds of results, you want to think about the kinds of ratings you have overall and the group differences. So for these results, we might say something like, ratings for the festival were quite positive. As festival goers spent more time at the festival, average overall rating increased. Specifically, those who had been at the festival more than 91 minutes rated the festival significantly more positively than all other groups. This is Jane signing off. Good luck and have fun.